The evolution of batteries and energy storage began in 1752 with Benjamin Franklin's famous catching lightning in a bottle experiment, where he used a kite, a key, and the world's first capacitor to capture static electricity during a thunderstorm. He was also the first person to use the term battery in his experiments with capacitors, but he couldn't control their discharge rate. In 1859, the first rechargeable lead-acid battery was created, and in 1970, Stanley Whittingham invented the lithium battery, but during its first test, it caught fire. He could never figure out how to make the battery safe to use, so he gave up. Although in 1980, John Goodenough was able to create a lithium battery he thought would be safe enough. For over 250 years, scientists have recognized capacitors are the most efficient way to store energy, but have never been able to successfully control their discharge rate, until now. In 2016, a major breakthrough occurred in capacitor energy storage technology by genius inventor Waseem Qureshi, who finally solved the multi-century mystery. His revolutionary SIRIUS modules make legacy electrochemical battery technology obsolete due to their vastly superior performance, lifespan, and safety. Waseem's invention combines an innovative supercapacitor design with ingenious firmware that controls their discharge rate. This groundbreaking technology is a critical catalyst for the age of electrification. It is important to understand the key differentiators that make SIRIUS modules so disruptive and why they supersede all legacy battery technologies. By design, lead-acid and lithium batteries use a self-destructive electrochemical process that continuously eats away at the inside of your battery. This is why batteries don't last and require endless, costly replacement cycles with perpetual nanny maintenance. Because SIRIUS modules store and discharge energy electrostatically, there is no material decay, which makes them virtually immortal. Additionally, batteries must be charged and discharged slowly, or they will form dendrites, which act like cancer or leprosy on the inside of your battery. Dendrites not only shorten your battery's lifespan, but significantly increase the danger of fire, fumes, and explosion. Since SIRIUS modules use electrostatic energy storage, there are no dendrites or self-destructive chemical processes. This is also why they can be charged significantly faster with zero risk of fire or explosion, and can be cycled millions of times, easily lasting over 45 years. Unlike batteries, SIRIUS modules operate across a wide temperature range, with no degradation in performance or lifespan, and no expensive heating and cooling systems to keep them from catching fire and exploding. In 2020, ASUS Group CEO Jason Marshall recognized how SIRIUS modules could significantly increase mission assurance and energy resilience to critical military, federal government organizations, and the U.S. power grid infrastructure. One of the most impressive SIRIUS module characteristics recognized by the ASUS team is their 100% depth of discharge.
The advertised capacity of electrochemical batteries is nowhere near what you can actually use. If the charge level in a lead-acid battery goes below 50%, it's an early death sentence as it significantly reduces its lifespan. If lithium-ion batteries are charged over 80%, They'll form dendrites, which reduce their lifespan and make them more susceptible to the risk of fire and explosion. As time passes, the usable charge in electrochemical batteries continues to decrease until they eventually become unusable. On the other hand, capacitors can be fully charged and discharged over 1,000,000 times with no degradation over their entire lifespan while maintaining a 99.1% round-trip efficiency. Think of all the time and money invested to maintain a battery backup system that fails when the emergency hits. All for nothing. On the other hand, capacitors can sit for decades with a full charge or no charge, with no nanny maintenance or service requirements, whether sitting on the shelf or being used operationally. The savings in time and money, as well as the reliability, safety, and peace of mind that comes with such a revolutionary energy storage solution is tremendous. When it comes to military operations, capacitors are perfect because they don't produce any traceable heat signature and are extremely resilient. You can burn, short circuit, puncture, pound, or drown capacitors in our SIRIUS modules, and they just keep working. Since they charge so much faster than lead acid and lithium batteries, generator charge times typically decrease from 60 to 85%. This not only saves considerable generator fuel and maintenance while extending the generator's life, but from a tactical standpoint, it enables longer silent watch and silent run periods for military forces with far greater safety benefits for its personnel. For example, one of the biggest challenges in the world of lithium-ion batteries has been their high risk of fire and explosion. Lithium fires burn until the lithium's burned up, with little regard for any amount of water. This is why countless people have been injured or killed from lithium battery fires or explosions, to include firefighters. And it's also why there are so many special handling, transportation, and storage restrictions that require massively expensive ecosystems, from fire suppression to climate control to end-of-life disposal, and on and on. Our supercapacitors and our SIRIUS modules use graphene and electrostatic-based energy storage, so they can't catch fire or explode. They're more of a fire block than a fire hazard, and can be safely transported even on aircraft. In spite of all their hazardous characteristics and massive life cycle costs, lithium-ion batteries have become common due to their energy density, which is a measure of the amount of energy that can be stored in a given amount of mass. Although our SIRIUS modules exceed the energy density of lead-acid batteries and are currently on par with lithium-ion phosphate batteries, we are projecting energy density advancements that will exceed any existing energy storage solution currently available. And don't forget, 100% of the energy stored in our SIRIUS modules can be fully used with only a portion of the stored capacity of a lithium battery that can be used. Another major problem with lithium-based batteries is their supply chain. 80% of the world's lithium batteries are manufactured in China. Plus, lithium's a hazardous rare earth metal, often mined in conflict zones, projected to run dry well before they're able to come anywhere close to satisfying the energy storage demands that are upon us. Conversely, the supercapacitors in our SIRIUS modules use graphene made from graphite, which is plentiful in the US, making them 100% green, easy to recycle, and completely eco-friendly. Given all the advantages, SIRIUS energy storage modules represent, the total cost of ownership is significantly less than lead-acid or lithium-based batteries. The fact is, the current levelized cost of energy for SIRIUS modules is so low it already meets the 2035 targets set by the Department of Energy. Near-term increases in our SIRIUS module energy density only continue to further improve this most important cost metric. Think about it. For centuries, scientists have understood that if they could control the discharge rate of a capacitor, it would result in the perfect battery. Our SIRIUS modules have finally proven them right. When you consider the performance, long life, safety, environmental, and total cost benefits of SIRIUS modules, it's easy to see why many are calling this the world's best battery.